All right, so we will start today's session, and the topics that we will cover in today's session are branching and iteration in programming. So last time we saw that we talked about what a computer is, and it does not do anything by itself. What it does is operate some programs, operating system, for example, Windows is one of them, and they're all written by programmers. And what we talked about was how to develop simple programs, what's included in them. We talked about the syntax and semantics of code. We talked about some scalar objects, objects that have a single value like integers, floats, and booleans. We talked about some simple operations and what's the meaning of expressions, variables, and their values. What we will talk about today is a new object type, which is called a string. These are basically a collection of characters. We will talk about how the flow of control within a program works, and how do we branch into multiple options of operations, how to do that, and what are the conditions, the way it evaluates conditions and then executes some expressions under them. We will talk about indentation. That's how Python keeps its code readable. And lastly, we will talk about iteration or repeating certain parts of our program and loops. We will talk about two different kinds of loops. So coming straight to strings, they are letters and a collection of letters, special characters, spaces. It could be numbers as well. The way we define them in Python is by enclosing them in double quotes, either double or single quotes. For example, here we say that hi is a variable, which is just, okay. So we say hi is a variable that has a value of hello there, okay? No space before H and no space after E, but there is a space between the two words hello and there. So the collection of these characters makes up the value of the variable called hi. What we can do with strings is that we can concatenate them. We can do some operations on them. Concatenation is one of them. For example, I say there is another variable called name. It has my name as a value. And then I'm defining another variable called greet, which is the concatenation of the whatever the value was of the variable hi, and then whatever the value was of the variable name. Okay, so let's switch to Spider, and this is the code that I was just showing you. So we defined a variable called hi, a variable called name, and a variable called greet. So let's execute this selection here. I will use this icon, which is, you can also use the hotkey of F9 or click here. That will run the selected statements from within the code, okay? So it showed me in the shell that, okay, it defined three variables called hi, name, and greet. But I have not executed the print statement yet, which I can do now separately. And you will say that it said the value of hi variable concatenated with the variable, the value of the name variable. Okay. You will notice that this is a concatenation of just the simple value of these two variables, but they are connected together. That's because we did not put a space between them, which is in the next option. I will add that so that it makes a little bit more sense. So this is how you can, when you are showing certain values of strings to the users, you have to make sure that they also show up in a format which is readable. So I said, okay, greeting is another fourth variable now, which is the variable hi plus a space plus the value of the variable name. And when I print greeting, When I execute the print statement, now it is in a lot more readable format. There was a question, how did I quickly remove the hash mark, which is the keyword for making it a comment so that it's not readable or executable as a code. The hotkey for that is Control 1. I can turn this into comment so that it becomes you can see that it's this kind of looks disabled. The color coding is gone, which means this is not executable code at this time. If I click Control 1 once again, all the comment marks are removed and this code becomes executable. Okay. All right. So now the value of the greeting variable is hi plus space plus name, which hello there, Humayun. This now looks a little bit more readable. We can also do some other operations on them. For example, if we multiply a variable with a number, which is a string variable, and we are multiplying it with a number, what happens if we do that? So in Python, what it does is it repeats this string variable 3 times. Okay. So if you run the same statement now, for example, this says silly greeting, or silly is high value of the high variable plus a space plus the name variable times 3. Okay. So if I execute these two statements, you can say that it has the same greeting, hello there, but it repeated the value of the name variable 3 times. So this is a very simple operation that we can do on string, and we will look at a few more options later on. Here is another example of using the print statement in combination with strings. We say that x has a value of 1. If we print x, it would simply just print 1, but then I am converting here the value of x, which was an integer earlier. I'm converting it or typecasting it into a string. Now this xstr has the same value of 1, but it is now a string. The variable x is an integer, variable x underscore str is a string. And the reason for doing this is that sometimes we want to have variables in a format that we can run mathematical operations on them. That's how we do it. But there may be other occasions where we want to manipulate with what's inside the characters or what's representing as a character for the whole string. For that purpose, we sometimes convert it into string. Now, there are 3 different options of doing the print operation on them, and there is a little bit of difference here. You will notice that there is a string, my favorite number is, then there is a comma, then the value of the variable x, then another comma, then there is a period, another comma, and then I have another string called x is equal to, comma, and then the value of x. Let's see what this does in the code. So I will uncomment these statements with Control 1, and I say x is equal to 1, print x, and then convert the value of x into another variable, but typecast it into a string, so that I have another variable called x underscore str, and then I'm printing my favorite number is x, period, x is equal to x. Okay, let's see what this prints for us. All right, so it did the job. First, it printed x, which is line number 17, and then it printed this line number 19, which is my favorite number is 1, space, period, space, x is equal to space 1. And that's how this comma operator within a print statement works. All right. So what the comma operator within the print statement does is that it automatically adds a space between this value, this value, this value, this one, and the last one. So that's how my output looks. if I use the second statement, which is a combination of string concatenation here and here, but there is a comma after the first string, the output will be a little bit different. Okay. And you will notice that there is a space where there was a comma here, but everything else is just jumbled together because I used the concatenation operator between these strings and variables. The concatenation operator does not add any space by default. So this is still not that much readable, right? The last statement is there is no comma. It's all concatenations between static strings like this one and string variables like this one. Okay, if I execute this print statement, the output is again a little bit different. Now you will see that the space between is and the next one here, which is the value of x underscore str, is also gone. What I want to do is make it a little bit more readable. The first one was not good. Second also had issues. The third one as well. So whenever we are showing something to the user, we have to make sure that we have certain spaces added so that it's from an int format space, and then the value. Then I have a period. I can either put a space here after dot, or I can put a space here before x. So I want to not have any space between x is equal to whatever the value was. If I print this statement once again, this is now formatted a little bit better. I may also want to add a space between on either side of this equal sign. So that was some simple operation that we can do using the print statement, manipulating the variables that we have defined in our program. But sometimes it's not always the case that we just define everything within our program. What we want to do is get some values from the user as well. So for that purpose, what we will do is we will use um, the input statement so that the user can type something that we can use in our program, right? And that is done by this input statement. The format is that you have the keyword input, parentheses, and then a message within double quotes or single quotes, close parentheses, and whatever is written here is shown to the user. And then the computer waits for the user to enter something. Okay. So let's see how this works in our program. I will uncomment the next set of lines. And I say text is a variable name, which will get a value which the user will type as a result of this input statement. And I'm asking the user to type anything ... and then a space after that. So the cursor will be here after these 3 dots and an extra space. And it will wait for me to enter something. And whatever I enter, it's printing that text 5 times. Okay, so let's run these two statements. Okay, it said type anything, and it's basically now waiting for me. If I type the word 5, can someone tell me what it will do? 5 times the text 5.
We'll just print five times.
It will print 5 times, not 25.
No, I guess no.
Okay, right, you're right. Since 5 is a string here, by default, the input, whatever the user enters, it returns the value as a string. So text is a string here. And as we saw in the previous example of name times 3, it will print 5 times. 5 times. Okay. But we might not always need just the numbers. What if we need just the strings? What if we need a number from the user? What we have to do here is to typecast our input coming from here into an integer by using this function. Okay, now this int typecast, what it's doing is converting this input coming in from the user into an integer and then assigning it to the variable num. And then I'm saying again 5 times this variable num. The result here would be different. Okay, so it says type a number. If I say 5 this time, the answer will be 25. Okay, and the reason for that is I converted this 5 into the number 5, and then I printed 5 times num, which is 25, of course. Okay, so what happens if I do the same operation and I type something which is not a number? What will happen here? What's the next statement that's going to be run after I return this input back to the user on line number 29? It will try to convert it into an integer, and most probably it will run into an error. So we can see this angry text here that literal for int, which expects a base 10 input, is the A is not a valid input for that. So here we will talk about some exception handling and some other exception handling and some error handling later on in some future lecture. But at this time, we will just assume that the input, since we asked for a number, we will get a number as an input, and then we will do this operation of print 5 times num here. Okay, let's move on. What else can we do with these variable types, int, float, and string? We can have any kind of comparison between them, greater than or equal to, less than or equal to, and then there are these two logical operations of equality and inequality. Okay, we can say whether I and j are same. If they are same, it will return us a value of true Boolean value, otherwise false. And if you want to check if they are not equal, then send me true. That's where we use this not equal to sign in our conditions. Okay. There are two types of logical operations that we can do between Boolean values. They are and or. If you have studied propositional calculus or discrete maths, you would already know about this. Or if you have done any other kind of programming, simple programming, you would know. And means it would return you a true value if A and B are both true. Otherwise, it will always return you false. But the OR operator here is false only if both are false. If either of them are true or both are true, it will always return you a true value. Okay. And we will talk about branching, and that's where we will use these operations. Okay. This is another comparison simple example. We say P set time is 15 and sleep time is 8. So what happens if we ask it whether sleep time is greater than P set time? Sleep time is 8. 8 is greater than P set time. No, it's not true. This probably will return a value of false. Okay. Then we say, okay, drive is true, drink is false. Both would be drink and drive. And if we print both, it's false and true. False and true, according to this table here, is a false value. Okay, so when we print the value of this Boolean variable both, which is drink and drive, one of them is true, one of them is false, it will also return us a value of false. Let's look at this example here. So if we run all of this code, we get set time is not defined. Okay, I missed a variable. So we said set time was 15. Let's add it here. Oh, it's there in the comment above. Set time is 15. Sleep time is 8. And we print a condition of whether 8 is greater than 15, false. That's the first false. And whether false and true is true or false, that's also false. So this is a simple example of conditions or checking for conditions. All right, what happens, how do we use these in different types of games, for example? Let's say there is a maze and you need to find something within that maze. If you have gone to any physical maze, you would know that if they tell you that if you always turn right, you would eventually get to the exit point, or if you are trying to find something, you would find it. Okay, so I have 4 conditions here. I say if right is clear, go right. Okay. If right is blocked, then go forward. If right and forward are blocked, go left. If right, front, and left are all blocked, go back. Okay. If I follow these 4 simple steps, this is the path that I would follow in this maze. And what I'm trying to do is to find where the food was. And if I always keep turning right and turning back, if I end up somewhere which is completely blocked, I would eventually reach where the free food was. Okay. So that's how these conditions work in a program. And the syntax is very simple. We say, and there are different types of it. The if condition has a few few options. We can have just one condition. We can have one condition and one fallback if that's not true. And we can have any number of conditions and a final fallback if nothing of them is true. Okay. So we say if a condition, if this is true, run this. All right. We can also say if a condition, then run this. If it's false, then run this X portion. All right. But we might want to have more than one options. For example, if something is, if a variable is 1, run this. If it is between 2 and 5, then run this else if. If it is neither 1 nor between 2 and 5, then just execute the else portion. So if this condition here is true, it would go in. Otherwise, it would go to the next block. Any questions here? Seems simple enough, right? Okay. Let's see. So indentation, the concept of indentation comes here. You will see that there is a colon here after the if condition. So we say if, this is a Boolean condition, if x equal y, which is the equality operator. And then there is a colon, which is a keyword, which means the next block, which is 4 spaces forward, is part of this if condition, which is this one. All right. So we say, okay, we have taken an input, enter a number for x. We've converted it into a float number, which is a real number, into x. We got another number from the user using the input statement. We converted it into float as well, assigned it to the variable y, and then we are checking if x is equal to y. If yes, it will print that x and y are equal, okay. And as long as y is not equal to 0, it will give me a value of x divided by y. All right. You will notice that this is another if statement within the block of this previous if statement. And the statements that we want to run, if this is true, are indented another 4 steps forward. Okay. So that's how indentation works, and that's how the blocks of code are differentiated from each other in Python. Okay. Second part is if x is less than y, then we will print something, and if they're neither equal nor x is less than y, which means y is greater than x, which means y is smaller than x, then we will print the last statement and we will print thanks after that. Let's see this code here. Okay, Let's run all of it together. All right. So it just shows me the code once, and then it's asking me enter a number for X. Let's say 5. Y is 5. You want to go into that first statement, which is where X and Y are equal. Then it will check if Y, which is 5, not equal to 0, then it will also give me X divided by Y. Okay. And that's what it did. X and Y are equal, which is a result of this print statement. Therefore, X divided by Y is 1.0. If either of them was float, the answer would always be float. Just remember that. And you would, once you start programming, you will find out what the results mean if, what the value of operations are based on what the input was. Okay. And what happened after that? It went right away into outside of this. It did not go into the else if, it did not go into the last else if, and it went outside. So as a part of this block of if, else if, only one of them will be executed. And that's how we should be putting our conditions. If it goes into, it does not go into this else and goes into this elif, then the last else if will not be executed at all. Okay, so after this statement, it went completely outside of this if else if block and printed the thanks at the end. Okay, let's try different set of statements. Let's say it was 1 and 5, X is smaller, thanks. And if it was 5 and 1, Y is smaller. So that was a simple test of our block of if, else if condition. It will go into either one of these options. So what happens if Y was 0? It's doing a division here. If Y is smaller, but it's 0, and it can only happen if they're equal. So let's say both of them were 0, 0. So it said X and Y are equal, but it did not try to divide them, because here I have a check that Y should not be equal to 0. Otherwise, it would give me an error of division by 0. We don't want to get into that. Okay. All right. So what happens if in any of these, this is okay. We know X is less than Y, and this was an equality operator. What if by mistake we have X single equal to Y here? So what if is expecting is a value of true or false. Double equal is an equality operator. It returns a true or false. But if you have X is equal to Y, that does not return a true or false value. What it does is it assigns the value of Y into X. So that's where you would get a syntax error. Okay, coming back to that maze example, if any of you played games back in the 80s, probably no one other than, let me look at the participants. No one probably. So Legend of Zelda, the game is available now as well, but there was a forest in there, which if you kept going right, you would always just stay in the forest unless you go left. Okay, so the way it might look in the program is if you exit right, set background back to woods background, and then check again. If you exit still right on the right side of this window, this screen, then set background back to woods background. And if you still exit right, set the wood background back to the background back to woods. And that's how you will just keep on going unless you don't exit towards the right and exit towards the left. That's when you would exit back to the exit background. Okay. So what's happening here? We have an if condition. Within that, we have an if condition. Within that, we would have another if condition, and this keeps on going on and on and on. Is there a better way to do that? Yes, you would be stuck in a loop, and the programming part of it would become how would the programmer know how many times the user might try to go towards the right? 10 times, maybe 500 times, it just keeps on going. Maybe 1,000 times. So there is no way of you determining at the time of programming how many if conditions, nested if conditions you might want to put here. So the way to do that in programming is using loops. And while loop is first example of that. So here we would say while exit right, which means while the user keeps on exiting toward the right, just keep on changing the background to Woods background and go back to do the same check again, and then change it back. Keep on doing this until this statement in front of while becomes false. If that happens, then go out. Okay, and then change it to exit background. So we have converted this endless nested set of if conditions into just two lines: while exit right, set background back to Woods background. And as soon as this becomes false, it would get outside of the while loop. So that's an example of using loops as part of repeating a set of statements. So the syntax is that you have the keyword while with a condition. If this condition is true, this set of statements will be executed. All right. So let's say there is an example here, I think. Yeah, in your lecture code, you would have that as well. Okay. So, no, this one. I need to exit from here. Okay. Okay, so we are looking at this last set here. So you got out of the lost forest, so it's still using the previous input. Let's just break it here and run it once again. Okay. Yeah, there seems to be an issue here. Anyway, so it printed this statement for me here. You are in the lost forest. This is an example or just a depiction of the forest. The person is standing here, go left or right. Now our code says while n is equal to right or n is equal to capital right, you are in the lost forest. If not, if I write anything other than right, it would tell me that I got out of the loop. So if I keep on writing this or this, I would stay in here no matter how many times I do that. But if I say left, I will get out of the forest. Okay. So that was a very simple example of using the while loop for making that decision over and over and over again. Okay. So the way it works is that we have a condition. If we are using a number in here, we'll have to initialize before the while loop. And then there are certain steps that we do. One of them must be to change the value of this variable so that this condition changes every time. Okay. So we said n is equal to 0, and while n is less than 5, print n, but also increase the n value by one number so that it eventually it will become more than 5 or equal to 5, and then it would go out of this loop. Okay, let's try that. Okay, so it ran 0, 1, 2, 3, 4, and when it became 5 on the last iteration, when it printed 4, then it changed n to 5. And is 5 less than 5? No, it's equal to 5. So this while became false here after 4, and that's where the program ended. Okay. Now there is another for loop. There is another loop construct within Python, and that is called for. And this kind of operation where it's where our decision is depending on a comparison of numbers, and and the number is being incremented by a certain integer value, we can convert these 4 lines into these 2 lines very simply. So here what we are saying is that for n in range 5, which is from 0 to 4, 0 to 5 minus 1, I will come to this details of the range function in a bit, do something, okay? And here we had to initialize n, and then we had to increment n, although we have a condition and a print statement. But we can do all of this with simply writing for n in range 5, print n. And that would do exactly the same operation for us. 0, 1, 2, 3, 4. Okay. So what does this range function do for us if we are using for loop? So the syntax for is for some variable, which is the variable for the for loop, in range, which is some number, do something. Okay. Now this automatically increases the value of the variable by 1 every time it goes to the end and then back. For the next iteration, this variable will be incremented by 1 already. Okay. So that this is different every time, and by the time it reaches some number minus 1, it would go out. Okay. But there are some more options available here as well. The actual format for using range is range, a start value, a stop value, and a step value. So we might not always want to start at 0. Okay, and we might not always do the increment by 1. So that's where the start and the step come in. But if you don't give it all 3 values and give it just 1, that would be the stop value, right? So here we said 5, just 5, that was our stop value. And it always loops until the value becomes stop minus 1. Okay, so that's why when we had 5, it stopped at 4 here. All right. So what happens if we use either 1, 2, or all 3 of them? Step by default is 1. If we give it 2 values, they will be considered to be start and stop. If we give it all 3 values, that start, stop, and step. Okay. So in this example, we said my sum is 0, and for I in range 7, 10, I'm increasing or incrementing or adding whatever that value was into this variable called my sum. So the first time it will be 7, second time it will be 8, and third time it will be 9. It won't execute when it is 10 because that's 10 minus 1 that becomes false. So it would execute 3 times. It would add 7, 8, and 9, and that would be the value of my sum printed here. Okay. Let's look at it in code. So I said my sum is 0, and for I in range 7, 10, it will start at 7, it will go until 10 minus 1, and it will put whatever that value was as an increment into the value of my sum, which started as 0. Okay. And the answer for that would be 7 plus 8 plus 9, which probably is 24. Yeah. Okay. But what happens in this set of statement? We said my sum is still initialized as 0, but then we want I to start at 5, end at 10, 11 minus 1, but increment every time by 2. So first time it would come in as 5, and second time it would come in as 5 plus 2, 7, and third time as 9, and 11 won't execute. Okay. But there is another option here, and let's talk about that first. What if we want our loop to end before reaching its conditional end? To do that, what we do is use a break statement within either a while or a for loop. What break does is it stops the execution of the innermost loop it is in and goes outside after the end of it. Okay, so we said while condition one, then we have another while loop called checking for condition number two, and it's executing an expression, and then we are breaking here. This expression will never be executed, and this break will take us to the statement after the end of this while loop. Okay, so it would run expression A if this condition is true, and it would break and go on to run the expression number C, after which it will go back to the beginning of this while loop. It would go again and check again condition number two, and then expression A will be executed. Okay. I believe, yeah, we have an example for that here. And what it did is it started with 5 because my sum was 0. The first for loop is checking, is adding this first value, which is 5, into my sum. My sum becomes 5. And we are saying if it is 5, then just break. So even though there are more options to just keep on going here, go on until 11, increment by 2 every time, but we have a break statement here which breaks it on right on the first value. Okay, we could change this to, let's say, 9, and the first 2 runs of this for loop will probably execute, and the sum would reach 21 before it finishes. Okay, and that's probably because the previous value started with 5. Okay, so that's how the break statement within either for or while loop works. And this is the example, yeah, that we just saw. It will start with an initial value of 5. It will add it to this 0. So my sum becomes 5. And here we are checking if this is 5, then just break. This my sum plus equal to 1 will not work. Plus equal to is same as my sum is equal to my sum plus 1. This is another way of writing that my sum plus equal 1. Okay, so this print my sum would print only the first value of 5 because we are breaking right after that. Nothing else would execute after that. Okay, last thing for today is a simple comparison between the for and while loops. And when should we use for, when should we use while? So if we know the number of iterations in the beginning, like using the range function for that, then we should use for loop. While loop is usually used when there is a logical condition that might change as part of executing the loop. Okay, so if we have a known number of iterations, we should use for, but if we don't know the number of iterations in the beginning, then we cannot use an iteration variable like we have in for. For that purpose, we should have a condition in front of the while as a logical condition. For can end early if you use a break statement, so can while, no change here. For loop uses an inbuilt counter as part of its definition. The while loop can use a counter, but there may be operations that don't even use a counter. But if you are using a counter, you must initialize it before and increment it during the loop. Otherwise, it will just keep on running forever. So in a while loop, we have to initialize a variable and then increment a variable. In a for loop, we don't need to do that because it does it for you. And lastly, you can always rewrite a for loop using a while loop. You can convert a for loop into a while loop almost, not almost, but every time, yes. But a while loop, you might not always be able to rewrite it as a for loop. And that's because while loops allow you any kind of logical conditions, which within for it is just running on a counter, and your condition is based on the value or a number of iterations of that counter. I believe that brings us to the end of this this lecture. This code file was given to all of you. There are a couple of other one more example here. Let's just run it before we finish. So what it's doing is we say that answer is 0, negative flag is false. Let's see what that's being used for later on. In line 120, we say, okay, enter an integer. We are converting it into an int, assigning it to the variable x. If it is less than 0, we say negative flag is true. And while answer raised to the power 2 is less than x, answer is equal to answer plus 1. And remember, we initialize that with 0. And if answer raised to the power 2 is exactly equal to x, then square root of x is answer. Otherwise, we say x is not a perfect square. So a perfect square is an integer number that has a square root, which is also an integer. Okay. Let's run it and try to enter different options of input and see what it does for us. So it says enter an integer, 5. 5 is not a perfect square. Okay, let's run it again. Let's give it a perfect square. Let's say 16. So square root of 16 is 4. Okay, what happens if I give it a negative? It's using this negative flag here. And so what happens if I give it a negative number? It's saying minus 16 is not a perfect square. And just checking, did you mean 16? And that's this condition here, which is giving us this option. So this else part means it wasn't a perfect square because we could not find this answer until we kept on increasing it. We reached all the way to x itself, and we did not find a statement or a condition where answer raised to the power 2 was equal to x. Okay. So this wasn't printed. This was printed. It's not a perfect square. And if it was negative, which we checked over here, then we printed a statement that it's just checking, did we mean minus x? So whatever the value of x was, which was minus 16 here, it printed the negation of that, which is plus 16. So in a way, it's asking maybe you made a mistake, entered minus 16. It could not be a perfect square because it has a negative in front of it, and no two positive or two negative numbers can be squared to be minus 16. So it's just checking, did you actually wanted to enter 16? Okay, just a use of creating this negative flag, setting its value, and then using it in our decision-making process. Okay. There is a small question here. You can try it out when you have time after the class, before the next class. That just instead of asking it, if you do get a negative number, just try to give it the answer. Okay. Anyway, before we finish, any questions?